Okay, let's move on to our actual proof of L'Hopital's rule. So in this video is going to serve as kind of an introduction. What I'm going to be doing is proving Cauchy's mean value theorem, and this is going to be a tool that we use in order to help us prove L'Hopital's rule. So what Cauchy's mean value theorem says is also called the general mean value theorem. It says that f prime of c over g prime of c equals f of b minus f of a over g of b minus g of a if both f and g are differentiable on the open interval ab, f and g are continuous on the closed interval ab, and then g prime of x cannot be equal to 0, so we don't have any divide by 0 errors. Before we go any further, let's think about this graphically. So if you have our two axes right here, this is going to be g of x, this is going to be f of x, and we'll just choose two random points and connect them, get something like this. So this right here is going to be g of a, and this right here is going to be g of b. And then we have f of a and f of b. So Cauchy's mean value theorem guarantees that this average rate of change between these 2 points right here is going to equal the instantaneous rate of change at some point c. So this would mean that this is g of c and this is f of c. So to start the proof, let's think about this line right here, the average rate of change. So we have a couple different ways we can represent the equation of the line, but I'm going to use point slope form, which is y minus y1 equals the slope m times x minus x1. And then before we do anything else, I'm just going to add y1 to both sides in terms of y. So you get y equals y1 plus m times x minus x1. So now let's apply this to our actual function. So we get y equals, so y1 is going to be our first value along the y-axis, f of a, plus m, our slope. So our slope is going to be our average rate of change. So like think y2 minus y1 over x2 minus x1. But in this case, it's going to be f of b minus f of a over g of b minus g of a. Okay? Times x minus x1, or in this case, g of x minus g of a. Okay, so now what we're going to do is we're going to define a new function, h of x. So we're going to define h of x. We're going to define h of x to be the difference between our function and our average rate of change. So this difference right here is going to be h of x. So as an equation, it's going to equal f of x minus y. So this is going to be our y right here. So let's plug in y for h of x. So we're going to say h of x equals f of x. Now it's important to remember to distribute this negative sign to all our terms. So we're going to get f of x minus f of a minus, and our slope f of b minus f of a over g of b minus g of a times g of x minus g of a. What we're going to need to use is Rolle's theorem. So what Rolle's theorem says is that there exists a point c such that h prime of c equals 0 if h, the function h, is differentiable on the open interval ab and continuous on the closed interval ab, and then both are endpoints, so h of a and h of b both have to also be equal to 0. So we know that h is going to be differentiable on our interval because it's just the difference of two differentiable functions. So but we still have to check our endpoints, h of a and h of b, in order to make sure that we can use Rolle's theorem. So let's check h of a first. So all we have to do is plug in a for x in our function h of x. So we're going to get h of a equals f of a minus f of a minus f of b minus f of a over g of b minus g of a times g of a minus g of a. So you can see here, it's pretty simple. These two f of a's are going to subtract to be 0, so you get 0 minus, well, these two g of a's are going to subtract. So we got 0 minus 0 times the slope right here. So this is all going to be equal to 0. So our first endpoint, h of a, is good. Now let's check the other endpoint, h of b. So h of b is going to be f of b minus f of a minus, same slope here, f of b minus f of a over g of b minus g of a times g of b minus g of a. So now what you'll see here is that g of b minus g of a here in our denominator cancel, and we get f of b minus f of a minus f of b plus f of a, which is also going to be equal to 0. So both the endpoints are equal to 0, and we can use Rolle's theorem. Okay, so therefore, there exists some point c where h prime of z of c, is equal to 0. So now we're going to have to take the derivative of our function h of x. When we look at our function, f of a is going to be a constant. This whole slope thing right here is going to be a constant. And g of a is also going to be a constant. So when we derive to get h prime of x, so we're going to get f prime of x minus, this gets multiplied, it's still a constant, so f of b minus f of a over g of b minus g of a times g prime of x. Okay, so now let's check our point at the derivative of point c. So when we get h prime of c, we know this is going to be equal to 0. So now let's plug in our point c into this derivative right here. So we get f prime of c minus f of b minus f of a over g of b minus g of a times g prime of c. Okay, how to get a new piece of paper, but we're right where we left off, plugging in c to the derivative of h. Now we just need to do some algebra, and we're almost done with this proof. So let's subtract f prime of c from both sides. So we get negative f prime of c equals negative f of b minus f of a over g of b minus g of a times g prime of c. Now we just need to divide both sides by negative g prime of c. So we get f prime of c over g prime of c equals f of b minus f of a over g of b minus g of a, which is Cauchy's mean value theorem. Alright, so we have finished our proof. One last thing that's kind of interesting to note is that this is the general mean value theorem, and if we plug in the specific case where g of x is equal to x, we'll get our regular mean value theorem, because this is going to mean that g prime of x is equal to 1. So f prime of c over g prime of c is just going to be f prime of c, because the denominator is 1. So we'll get f prime of c. F of b and f of a are going to stay the same, and because g of x equals x, the bottom, the denominator, is just going to turn into b minus a.